start with are these small angle results. The first thing you need to know with small angle results is this. I guess you can say it's a property, but you can say it's a formula as well. So the limit as x approaches 0 for sine x on x. Now, obviously, we understand as x approaches 0 here, anything on 0 is undefined. But sine x on x, now you can do the proof of this. There's a nice geometric proof for this occurring. We're not going to do it right now. But the limit as x approaches 0 for sine x on x is always going to be 1. As long as this x and this x are the same, the limit as x approaches 0 of sine x on x is always equal to 1. So that means the limit as x approaches 0 for sine 5x on 5x equals to 1. Right? As long as the angles are the same, always equals to 1. So easiest 2 marks that you can get. The thing is, you're going to get questions like this that obviously say x on 3x. So the trick is to make them the same. Make them the same. Oops. And then I'm going to say match the trig. Match the trig. So here, you're obviously going to make them the same. Now, are you actually going to make the x into 3x or the 3x into x? Match the trig. What would you do?
Would you make the top 3x and
the problem with making the top into 3x is that this is actually an angle. Now imagine you wanted to make this into a 3x, right? How do you make sine x all of a sudden become sine 3x? Give me an idea. You'll say, oh, Sam, times it by 3, right? Well, if you said times it by 3, it would look like this. 3 times sine x. You can't actually change angles. So match the trig means exactly what you see in your trig function. So sine 1x, the bottom's got to become (1x) as well. Now obviously that's not allowed. You can't just make the 3x into an x. So what you do, you're taking out the 1/3. A third times this is back to this original question. But what do we know the answer to this bit being? Obviously 1. 1/3 times 1. The answer is just 1/3. We need to see the times 1. You don't write times 1, you don't get the second mark. You only get 1 mark. Are we thinking why? Because we need to know that you actually used this formula. Any questions? This formula is also true for tan. Limit as x approaches 0 tan x on x also equals to 1.
So Sam, do we have to make it always equal 1?
Yeah, that's the idea. It's you're meant to get this bit at least becoming 1.
Okay.
So next one here. It says 4 tan x on x. Are the angles matching?
Yes.
So then therefore your answer is going to be 4 times limit x approaches 0 tan x on x. These are already the same, so equals to 4 times 1, which equals to 4. Let's try it again. Equals, are the angles matching? No, you've got to make them the same, match the trig. So Alex, what would you write? Limit x approaches 0, tan 5x on
5x.
5x. Now, you know that's not allowed. You can't make this x into a 5x.
Yeah.
So what are you going to times this by?
5.
What's 5 divided by 5?
1.
So you technically multiply by 1, which is great. You haven't changed the question. But what's the answer now to this bit?
1.
So the answer is 5 times 1 equals 5. Next one. Anyone see a pattern yet? Or not yet? If not, we'll keep going. Who wants to try this one? Come on. Azra, let's try it. Limit x approaches 0, sine 4x on.
Would you make it 4x?
Correct. So now the angles are matching, but you needed a 3x in the denominator. So what are you going to times the top and bottom by to make it back to a 3x, to make this 4x into a 3x? Anyone have any ideas? Help her out. She's got a 4 here. I'm saying, what are you going to times by to go back to your 3x? Think about it. You don't want the 4 there. What number goes on top? And then what number goes on the bottom? So that you get back to 3x. Alex, take a guess.
I don't know, maybe.
Guess, yeah.
12?
12, all right, good shot. 12, what's 12 over 4?
3?
3, but you're going to have 3 on the top now.
Yeah.
Yeah, see, it's good. At least you get to see what happens. Come on, someone else. Or Alex, try again. Try a different number now. You want 3 in the bottom. What are you going to write here? What would you write here to get rid of this 4? You guys are overthinking it, but I would like to not give you the answer just yet. Say it again.
4.
So what would you put on the top, Alex?
Or do you just get rid of the 4?
So what would you put on the top? 4, right?
4, yeah.
And then what happens here? 4 over 4. Now you've got 1x. What are you going to put at the bottom?
3.
Yeah. What happens? 4s will cancel out. And then that just becomes 3x. And then that becomes obviously 4 over 3 times 1 equals 4. Azra, does that make sense?
Yeah.
4x times, 4 over 3. You're going to get rid of your 4s. And then, of course, 3's in the bottom. Last one. Limit x approaches 0. Sine x on 2. All over. It's going to be x on 2. But you didn't need x on 2. You needed a 1x. So we're going to times this by. Well, you're going to times it by 1 over 2. A half. 1 times the top is 1. 2 times a half on the bottom is back to 1. That's a tricky one for a lot of students to see. So 2 times a half is actually going to get you 1. Now, I will tell you how I get these answers. Because I obviously don't do what I'm teaching you right now. Right? What I do is this. I go, what's x divided by 3x? What's the answer? The answer is 1 over 3. But what I know, so I now know the answer, but what I know is I have to get my full marks, I've got to show them this. So what I do is I usually get the answer, which is a third, and then I just pretty much write limit x approaches 0, sine x on x, just to show them that I've actually done the math, and then voila. So here, this is already x on x, which is 1 times 4. I already know the answer is going to be 4, and then I just show it. This one, the answer is 5x on x, which is 5, and then I just show it. The answer here is 4 on 3. There it is. Ah, did I write 4? On 3 times 1 is 4 on 3. There it is. The answer here is half divided by 1. So x on 2 divided by x is just half. So I know the answer is a half, but I'm just showing them the matching. So I already know what to times by. Do you guys get what I'm saying by that?
Yeah.
100%?
Yeah.
Okay, anyone not get it then? Well, let's have a look at just 2 or 3 more. Limit. So you pretty much know the answer. Limit x approaches 0. X approaches 0 for tan 5x on 3x. Well, you kind of know the answer. What's the answer, Alex?
5 on 3.
Right, so the answer looks like this. 5 on 3, limit, x approaches 0, then you just try to show them that you've done some work, but in reality, you already know the answer, which is 5 on 3. And no one needs to know that you've just done 5x on 3x. But that's the trick to it. That's what obviously everybody would do. All right, sweet. So easy 2 marks. It has to be done like that. If it's a multiple choice, it's obviously worth 1 mark, and no one really cares how you've done it. So, cool, easy. Now we get to sketching. All right. So before I start, we need to just draw our basic one. Sketching, trig, functions. So in trig functions, you've got a few things that you need to know. You've got what is called period for your sine and for your cos. Your period is 2 pi on n. For tan, it's pi on n. So for period, sine and cos, it's 2 pi on n. Tan is pi on n. What is n? N is in front. N is the number in front of your angle. So if I said sine 2 theta, n equals 2. If I said sine 3 theta minus pi on 2, your n is still 3. Okay? Period just means, I guess, how many times sine, cos, or tan would occur. So I'll explain that as we do a few more, but you'll need to know period, and then the next word is called amplitude. Amplitude is just your highest and lowest point. So pretty much how high and how low your trig curves will go. For sine and cos, your amplitude is the number in front of your trig. So if it says 2 sine 3 theta, your amplitude is 2, your period is 2 pi on 3. Do we have any questions? L, Azra, all good?
Why is the
Yes.
period for the last example you did
Yes,
2 pi on 3?
because the formula is what?
Oh, 2 pi on n?
For sine and cos.
Okay.
And tan, as you can see, doesn't have amplitude.
Yep.
Tan goes up. It doesn't really have amplitude.
All right.
Good. 2 pi on n. Period. Period is just how many times you'll see one sign, but I'll explain that in a second still. Okay. Any questions? No? We're good? We're good. Then we need to know our basic shapes or basic curves. So for y equals sine theta, you've got to memorize it looks like this. Sorry, 2 pi, 360 degrees, pi and 0, goes up 1, goes down -1. Y equals cos x or cos theta. Some see it as an upside down cowboy hat or whatever you guys want to call it. There it is. Again, 1 to -1, and then we've got y equals tan theta. Tan 90 cannot be a solution because of Pythagoras' theorem. You can't tan 90 degrees. So that would be pi on 2, and that would be pi. And do we have anything else? Not really, because our period is every pi. Okay, so let me just show you how this works in terms of this graph. Look, for sine and cos, we said it's 2 pi on n, right? So what's 2 pi on 1? Well, 2 pi on 1 is 2 pi. So period tells you that you should see one sign, there is one sign, every 2 pi. L, do you get that?
Yeah.
One more time. If I've got a period of 2 pi, you see one sign every 2 pi. My amplitude is the number in front, so it's 1, so go up 1, go down 1. Again, my period here is 2 pi on n is 1, so that means I should see one cos, which is exactly this shape, every 2 pi. One period. Period is 2 pi. I should see one cos every 2 pi. If my period was pi, I should see one cos every pi. That's how we read periods. Period is pi on n. I should see 1 tan, which is this shape, every pi. I should see 1 tan every pi. Okay, if you can say it the way I'm saying it, I don't see you going wrong. Let's try to graph this first one. Y equals 2 sine 3 theta, sketch this for 0 to 2 pi. All right. So, what do we know? Tell me the two things I know from this equation.
The amplitude is 2.
Amplitude is 2, perfect, and your period is then 2 pi on
3.
3. So you should. How do we interpret period, Alex? Every 2 pi on 3.
You should see a sign.
Say it again.
You should see like a whole sign, like curve.
Yeah, that curve. You should see one sign. That's one sine curve.
Yeah.
Every 2 pi on 3, I should see one sine curve. Cool? If you don't know how much 2 pi on 3 is, Use degrees, 120 degrees. Good. Watch. That's 120 degrees, 2 pi on 3. I see 1 sine. 2 sines. 3 sines. 6 pi on 3, which is 2 pi. Yeah, period amplitude was 2 to negative 2. 1 sine, 2 sine, 3 sines. Does that make a lot of sense or what? Because I can't make that any easier. Elle, what do you reckon?
Makes sense.
Just a little bit more or a lot more? A little bit?
Yeah.
I need to know what bit you're fully getting and what you're not getting with this.
Yeah.
Say it again.
It makes sense.
And what bit it confuses you about trig functions?
I think it was when
Movements,
like
up, down.
like
Sorry,
when you shift it like left and
Yeah.
right.
Yeah, done. I'll do those ones in a second.
Yeah.
Good. So, everyone happy with that? I mean, look, if your domain was different, if it was, I don't know, 0 to pi, 180 degrees, you know that's 120, that's 240, that's 120. Halfway between 120 and 240 is 180. So you would just stop it there. And then that would have been your answer for that domain. Right, so you don't worry about the domain so much. You draw your graph properly first, and then you can rub out the bits you don't want. You can highlight the bits you want, whatever. That's how personally I did it in my exams back at your time. Back in my HSC years, I would have just left my graph and then highlighted, or the other version that I had created was just to cross out this and say, don't mark, and then say, here, mark. So whatever, doesn't matter. All right. I just want to have a quick look at those ones, see if there's anything that has movements, and if they don't, no, none of those are movements. Let me see from this booklet, I'll find some movement questions. There we go. All right. 3 plus 2 sine x. Are we doing all these to 0 to 360? I'm guessing, yeah, 2 pi. All right. So I do them a little bit differently, my movements, compared to the way you get taught at school. So let's see if you can understand what I'm about to do here. So L, let's do this one. This one's not that difficult because it's just an up and down. Up and down are usually easier than left and right. But tell me, what's my amplitude, firstly?
2.
2. And what's my period? 2 pi on n, which equals 2 pi on
1.
1, which is just 2 pi.
Yeah.
So every 2 pi, you should see 1 sine. And we know that the domain is 2 pi. So, oops. So we're going to see exactly 1 sine within that. So that's not a problem. And then shift the whole thing up 3. So this is what you get taught at school. I just want to show you what you get taught at school. Voila, whatever, 2 pi, pi, 0, 2, minus 2, and then they tell you to shift this whole thing up 3. Is that correct? Is that how you got taught? I don't know. Tell me otherwise.
Yeah, that's what we did.
Yeah, I don't do that. What I would do is go, okay, wait. Instead of moving this whole graph up 3 units, why don't I actually move this axis? What am I going to say?
Move the axis up.
Oh, not up, down. You do the exact opposite. So I'll move the axis down 3.
Yeah.
So instead of it being at 0, what does this become now, technically? You're going to move it down.
-3. Oh.
Yeah, that's the idea. So let me show you what happens. So if you're going to move this up, if you're going to move this down 3, this 0 will move all the way down to technically -3, right? Where your -3 is meant to be. So that becomes your new 0. Let me do it in a. It might be a bit new at first, but if you do it, it makes your life a whole lot easier. So that becomes your new 0. So technically, what number is this now?
3. Oh,
Yeah, and then what number is this?
Um,
And what number is this?
5.
See how much easier it is to do that way? So
yeah.
technically, you are adding 3. Why did you want to actually go ahead and draw this new graph shifted up 3 when you can just move your axis down 3 and voila, it looks like it's been shifted up 3, doesn't it?
Yeah.
Amazing, right? That's how I'm going to do it. So that's how you'll do it as well. There's no way a proper person like at my level would ever want to redraw this up, down, left, right 3-4 different times when these questions get harder and harder. So what we do, we actually change our axes, and that's the proper way you're meant to be doing these graphs instead of the way you guys get taught. And that obviously works for all cases. I mean, you could have done it for your parabolas, but it's just a lot easier to say with parabolas just to shift this thing up 5, because it's just like, it's pretty symmetrical, it's pretty straightforward. These ones here, because they're what we call oscillating functions, they get pretty tricky to move up, down, left, especially left and right. So we just go, okay, just change your axes, they're a lot easier. With you, Azra, for example, when you're doing inverse functions, you should be also doing the same thing. In extension. You can hear my little girl talking back to us. All right. Cool. L, makes a lot of sense,
Yeah.
or a little bit.
I know, it makes a lot of sense.
And do you feel like you can apply that now to your questions?
Yeah, definitely.
Okay, let's see. We'll do some more. All right. Negative sin x, I think we get the idea.
Sam,
Yes.
with that example, I did it like that in class, but I got in trouble for doing it like that.
Who got you in trouble?
My teacher,
Who's your teacher?
Miss Boggs.
Oh, I don't know who that is. Just go to Alexopoulos and tell him, Sam says, can I do this and will I lose marks? And he'll just say, no, you're all good.
Yeah, because she said that because I didn't show the original axis.
Well, what do you mean you didn't show your original?
I didn't show where the 0 was before.
Before?
Yeah, like the original where it's supposed to be, and then move it down.
Hold on. If you were ever... So wait, are you trying to say did you write a 0 down here?
Yeah.
Yeah, well, no, hold on. If you had this question, right, and you were going to do it, you're shifting, moving up and down, blah, blah, blah. This is what your graph would have looked like, right? It would have been 0, it would have been 1, 3, and 5. You would have shifted it up 3. You would have had to draw that. Now, how does that look any different to my one? Oops, I was meant to stop there. Oh, I can't even draw this. That's at 3. So how does that, there we go. How does that look any different to the one I've got? Oh, what am I doing? I can't even draw it. Look how bad I'm doing. There, from there. There we go. So where did you lose your mark? I'm confused.
I don't know, because I see it now. It doesn't touch that.
Yeah, no, it's meant to, like, see this line here. If you want to, and if you've done it in pencil, great, you can rub it out.
Yeah.
If you don't, you can cross that out and say don't mark. But if you're telling us that's 0, I mean, any person in the world can read that's 0, that's 1, 3, and 5. Doesn't matter even if you're like in year 7, you could read that properly. So But that's definitely full marks. I can tell you because I've been teaching that for the last 12 years. That's how I teach it.
Okay. I didn't know she just got me in trouble for doing it like that.
Don't worry. You tell me again, and if you ever lose a mark in your exams, I'll take care of it.
Okay.
Y equals sine x. Y equals sine x. I think you guys know what you're going to do with that one. There's your sine x. Just go the other way around. Those ones not a problem. Just do what you got to do normally. Let's see any other ones. That's not a problem. 2 minus, yeah. See it like that one there. Again, you got to shift it up 2. This is the way I would do it. I'm showing you how I would do this. I would first understand that, that's my sign. So I would actually draw my negative sign properly this way. Cool. I would actually draw it like that. And then I know I've got to shift this whole thing up 2 units. So right now it's at 1 and minus 1. I've got to shift it up 2 units. So I know my new graph, that's going to be at 3, that's going to be at 2, that's going to be at 1, which means my axis starts there at 0. There you go. You've shifted this whole graph up 2 units to the right. 2 units up, sorry. Steph, any problems?
No.
And it's a lot easier to do that than it is what you guys are being taught, which is move this thing up plus and minus. There's only a few teachers in the state that I know that really actually do it this way, because they understand it's a lot easier to teach this way than it is to move up and down. They're only teaching you up and down because that's the way you got taught with your parabolas and cubics. And they think it's just a lot easier to move what you've learned in year 10, year 11 to here. But it doesn't work very well with oscillating graphs. It's easy to move axes. Cool. That's a good one. That's a really good one, because this is the one that everyone gets wrong when they're doing it the normal way. So let's try it out. Y equals x less than 2 pi. We just got to remember that. My amplitude is 1. My period is 2 pi. Okay. My recommendation for any movements is to draw more than required. Okay, so draw more than required. So like that, and then let's just say you drew more. So draw 2. Don't worry, it's not going to be bad. Draw. Oh my god. There we go. That's a really horrible cos curves. Okay. Who wants to try this with me? Elle, do you want to try it with me? We'll do it together.
Okay.
Draw it out, and at least let's talk about it so you understand what's happening with each one. 2 pi, let's say that was 4 pi, and then just so you can see that's negative 2 pi. I'm doing it more so because a lot of students miss what happens when this is moving, and I prefer just to show you with more with a greater domain than a smaller domain, because you might miss some bits. All right, so let's have a look. Let's have a look at what's happening. Period is 2 pi. I think we get that. That's not an issue. X take away pi on 2. What does it mean?
Shifting to the right.
Yeah, so usually you'll be saying shift this whole graph to the right 90 degrees. Correct?
Yeah.
And the reason why I'm making you do this, you can see, there we go. Look, you can see what's going to happen. This is 3 pi, and this is what? Halfway between 180 and 540. 360, sorry, 360 and 540, halfway of that. What is that? 360 plus 540 divided by 2 is 450. Divided by 180, 5 pi on 2, obviously 2.5. Oh, that was stupid by me. Okay. Any questions now? Elle?
No.
I do recommend doing what I've just shown you, which is putting in as many of your I guess your intercepts and your numbers or your numbers. I don't know how to call what we call that, as you can. So 2 pi, 3 pi, and 2 pi. When you're moving left and right, when we're moving up and down, there's no dramas. Just move your axis, easy as. These ones here, you probably want to take a little bit extra caution by just putting these numbers in until you get stronger and stronger. If you want to do like 20 of these, you'll start to realize what happens, and then you might be fine. But for the time being, just do it like this. Okay, so we're here. You said move the whole graph to the right. I agree with you. So pretty much this 2 pi no longer becomes 2 pi. It becomes 2.5 pi. This 1.5 pi all of a sudden becomes 2 pi. This 1 pi becomes 1.5 pi. This half a pi becomes 1 pi, and so on. You agree with that? Ooh, all right. Let's do it. Let's say that again then. So you said move this graph 90 degrees to the right.
Yeah.
All right. So instead of it being at 0, what's it going to be now?
At
90.
Oh, okay.
And instead of it being at 90, what's it going to be now? 180. 180 is going to be at 270. 270 is going to be going to 360. 360 is going to be,
Yeah.
and you get here. Okay, now, instead of doing that, it's easier to move this axis. What? What am I going to say?
To the left.
To the left, 90 degrees. So where's it going to start? If I've got to move this to the left 90 degrees, where am I going to draw this? Here, tell me. Where do I draw my axis?
Where the negative is.
You are absolutely correct. So that becomes your 0. What number is this now?
The pi to 9 degrees. Yeah.
Do you get that? So that becomes technically, I'll use pi's, but that becomes 90 degrees. What number does this become now?
180.
Oh, how good is this? And that is your answer up to 2 pi. Oh, crap. Stuff that up again. Let's try again. Boom. Do you get it?
Yeah.
How easy was that?
Very easy.
Very easy. I say if you have tried it like you have at school, they overcomplicate it. Like Azra, now you're looking at this and you're probably just going to do it my way. But for those who have done it that hard way and then they understand this, they're like, what the? That's a lot simpler. It's just understanding what you're doing. You're moving 90 degrees. This one's going to be 360 plus 90, you're out. So you end there, you start here, boom, finished. Move this. If you want, why not? Now you know the shape, you know how it looks like. If you really want to, go ahead. There's 0 and start. There's 2 pi, there's pi. No one's going to stop you. There's 1, there's -1, whatever. If you didn't want to do that, most of my students just get taught to highlight it. If it's going to be like looking like the ones like mine, highlight everything. So it's just a bit easier to read. There and there. And that's it. So we'll know that that's 0 and that's your 2 pi. And that's the shape we're looking at to mark. Cool. All right. What do we reckon? Steph, Alex? Simple? Move it to the left.
Yeah.
Why do you want to move this whole graph 90 degrees? And then you're going to ask, all right, Sam, how do I know where to start? And it's just a mess. It really is a mess. That is simple. You just moved it and then you kept it as it is because there's nothing else to do.
Yeah, it's heaps easier like that.
Heaps easier. Heaps cleaner, I think, as well.
Yeah.
There's no movements. You're not doing anything. You're just changing the numbers around. All right. Let's have a look at this question. Maybe before we do that, let's do one more of these movements left and right. Let me just find one. No, that's it. Okay. There we go. Yeah, that's why your teacher's doing that, because all the books do it nothing. It's annoying. But the author of this book, I obviously have him on Facebook, Robert Yen. He was actually teaching this to another teacher, and it's funny, he didn't even follow this method. He obviously did the change of axes like I would. So this is just done because for the whole state. I mean, this is probably the easiest way to teach, but I don't think it's the best way to teach it. Okay. So let's try, wow, all that. Yeah, oh yeah, there you go. So he's trying to explain it here. You can see that this becomes this becomes this. It just looks complicated the way he's doing it. So that's pretty much how I do it. We move the axis instead of moving the graph. So he's pretty much doing it here, actually, in Maths in Focus. So let's try that one. Tan x plus pi on 4. Tan x plus pi on 4 in 0 to 2 pi. Maybe I'll give you guys just a minute just to draw it up. Y equals tan x plus. So there you go, Steph. You know how you just said I would lose a mark? All I've got to do is just print page 10 of this, and you can give that to your teacher. And so there you go. He's been doing it by phases anyways. So you can't say I lose a mark for doing that method. Tan x plus pi on 4 in a domain 0 to 2 pi. All right. So tan x, just in case you guys need it, look like this. That was 110 up to pi. But remember what I said with shifts, just draw more. Draw more to the left, draw more to the right, and then we can adjust. That's pi on 2. All right. Let you think about that. Okay. Let me try it as well now. Alex, let's do it together.
Sorry?
You want to try it together again?
Oh, okay.
So here we go. We've got this bit. We've got pi on 2. We've got pi, but then if you continue this, do you know what number this becomes? 90 plus 180.
What, 270?
You're going up by 90s, right? So yeah. 270. 270 divided by 180 is 1.5, right? So 3 pi on 2. And then again. Ugh. So hard to draw on this tablet. Ah! All right. I'm just going to draw it and get it out. Yes. Okay. 2 pi, and then again 5 pi on 2. You get the idea, Alex, right?
Mm.
And then same thing going down. What's my asymptote here?
Pi on 2.
Negative pi on 2, correct?
Negative pi on 2.
And then you just keep doing it. Start from up here to there. And then asymptotes, negative 3 pi on 2, and so on. Cool. You'll know how much to do it for. Like I said, if you guys do maybe 20 or 30 of these movements, you'll learn how much you want to draw, because you'll understand when it's plussing, you are shifting your graph to the left 45 degrees, let's say. You'll know how much more you got to draw. So you probably didn't need to draw all the way there, but for now, I'm happy with that. All right, Alex, what are we going to do?
Well, it's technically we have to shift it to the left,
So
right?
technically, you're going to shift your graph to the left, but instead of doing that, we can shift the whole thing
To the right.
Sorry, we can shift the axis to the right.
Yeah.
We're going to shift the axis to the right 45 degrees. So if I shift the axis to the right 45 degrees, my new axis is there. Do you agree?
Yeah.
So that becomes what?
0.
That becomes a 0. Instead of moving this whole graph to the left, I just move my axis to the right. That becomes my 0. And then, of course, what number does this become now? 90 take away 45. Right? Because it's 45 degrees closer. So this number now becomes
45.
45 degrees. So that becomes pi on 4. Pi, 180. You take away 45 degrees from it. So you're doing the opposite of this still. You are minusing pi on 4. As you can probably see. Here was 45 degrees. We minus 45. You got 0. Do you get that, Alex?
Yeah.
Yeah, and that's it. So 135 divided by 180. This now becomes 3 pi on 4. This was 270 minus 45 becomes 225. This becomes 5 pi on 4. 5 pi on 4. At 2 pi, 360. 360 take away 45 is 315. 315 divided by 180 becomes 7 pi on 4. So where's 2 pi? Well, 2 pi would be just a little bit more than here. So, well, if you don't know, work out what this was. So what was this? 180, and this was 270, right? No, that was 450. Sorry, 360, 450. What's halfway between 360 and 450? Why is my brain not working? 360 plus 450 divided by 2. Okay, this number here is 405 degrees. So what was that? 9 pi on 4. So this was originally 9 pi on 4. But when you're going to take away pi on 4, that's actually going to get you 2 pi. Wait, is that 5 pi on 2 the asymptote? It is, isn't it? Stop making mistakes. 360 plus like 5 times 180 divided by 2. Yeah, that's 450. So 360 plus 450 divided by 2 is 405 degrees, which is right here. So, Alex, this is 360. This bit here is 450. Halfway between them is 405 degrees, which is this one here.
Yeah.
And when you take away 45 degrees, that gives you your 2 pi that you're looking for. So you're pretty much stopping just somewhere there. Somewhere in midair. And that's why these graphs are really hard to draw, because as if you guys would have known to just stop there.
Mm.
You know? So the answer is this. I'll just highlight it. It starts like that, starts in midair, goes to pi on 4. Then goes like that, goes like that. Then you still got your asymptotes. Goes like that, goes like that, goes like that, and stops. Stops where this one started. So that would be really hard to draw if we had to shift this thing. Really, really hard. I don't even know how to do it. You want to see a computer generated one? There it is. So there, exactly where this stopped, where this one starts. All right, let's do it. What do you reckon? Do another one?
Yeah.
Yeah, let's do another one. Let's do another one. We just did that one, right? Sine. Let's take away. Visual extension 1. Combined transformations of trig. Yep, beautiful. All right, we'll do this one. Cos. Well, let's see if we can find even a harder one. It's the hardest one they've got. Maybe that one there. Let's try that. So y equals 8 cos x plus pi minus 3. Y equals 8 cos x plus pi minus 3. Okay, try that. I'll give you just a bit of a starting point. Draw your normal cos. Draw it for an amplitude of 8. And then do your translation to the left or to the right for your axis, and then you're going to bring the whole thing down through. So the minus 3 is the last thing. So first try to draw up that bit there. Okay. Let's try this. All right, here we go. So 8 cos x. So this is what I would draw. Whoa, that's a sine. And then, like I was saying just before, if you're going to move left and right, you might as well draw a few more until you learn which bits you do need when you're moving left and right here. What do we know? That's 2 pi. The reason why I'm stuffing up, just so you guys are aware of it, is I very rarely use radians when I'm graphing because I find them very complicated. So what I like to do is actually use degrees, and if once I've finished everything, then I go back and just convert everything into radians. But I was trying to just show you guys as radians. But if you're like me and you don't want to use radians, just convert them to degrees. It's a lot easier to add and subtract 180 than it is to fractions of radians. That's my personal opinion, but it's up to you. All right, that's your normal cos curve. There's your 8 and minus 8. Now we've got to move this whole graph to the left pi, or move my axis to the right pi. So that becomes my new axis, which is at 0. Right? I move my axis to the right pi degrees, 0. So what does that become now? You technically take away pi from that. So that just becomes pi. And then somewhere there would have been 3 pi. So take away pi would be 2 pi. And that's all we need to stop at. Do you guys get that?
I thought it was to the left pi units.
Wait, you're moving the graph pi units to the left. So with your axis, you'll do the opposite.
Oh yeah, that's right.
Graph to the left, that means your axis moves to the right.
Right. Yeah. Okay.
Yeah, I know. So it'll look like that. Do you get that though? How I got 2 pi and pi here? From where it had 2 pi and 3 pi before?
Yep.
Okay, perfect. And then yeah, you take away pi, and then pretty much that's at 8, that's 0, that's -8. Now you're going to go down 3. So what are you going to do if you're going to go down 3? This becomes technically, this is going to become 5. That's going to become 5. That's going to become what number? -3. And then that's going to become -11. So what happens when you're going down 3? What do you do with your axis? Do the opposite, go up 3. So somewhere there is going to be 0. And that is that graph. If I had a highlighter for you, there it is. Those are your numbers. And that is your axis, and that is your curve. Whoa. That is your curve. Stop. And that's where your 0 is. What do we think? Alex, L, Steph, Azra? Were we close? Did we get some of the numbers out? Obviously get some getting used to, but where did you go wrong if you didn't get this out? Was it the left and right, up and down, or we're just confused overall? Just start again. I don't mind.
Sam.
Yeah.
For the graph, like I know it's like not like super like symmetrical, I guess, on both sides, but we won't like lose marks, will we?
It is kind of symmetrical, isn't it?
Oh well, no, like obviously because mine, like I didn't do mine like with a rule or anything, and I just did a quick
Sure.
sketch.
Yeah, no, that's okay. That's
But,
all right.
So all we have to do is just like move like the axes like left, right, and up like that.
Yeah, that's it. So if you highlighted this, that means pretty much what you've drawn is this. So here's an answer that would be computer generated, right? You would have said 0 here. It would have had, it wouldn't have shown you -3. It would have just shown you -11, and it would have shown you 5, right? And then it would have shown you at 0, so it would have started off at -11, it would have gone up to 5, and then it would have come down to 2 pi. And that's it. That would be the answer, and that's literally what you have. Pi, 2 pi, 5, -11. You just wouldn't have seen -3.
Okay.
So it's exactly the same answer.
Yeah.
It's just, I feel like over the years, I've realized I haven't had even my top students understanding it this way. But I've had every student understand this without any issues. So I've pretty much got rid of that, you know, just move it left and right business. I just do it through axes now. So I mean, there's nothing stopping you just to go ahead and redraw this if you wanted to, and you don't like this highlighting business. Let's do another one. Elle, did you get it out, or you went wrong somewhere? And where did you go wrong if you did go wrong?
I got it. It was just hard with the radians.
These radians, right? Yeah, look, the next question I'll do, I won't do it with radians. You'll see it's 10,000 times easier to not do it to radians and just do it with degrees.
Yeah.
Because I think, like, if with this question, originally this was 2 pi, so if that was 360, and this would have been 3 pi, so what's 3 times 185? 40. If I knew those were 360, 540, and that was 180, and so on, and then now you tell me, hey, go and take away, wait, if that was 360, no, sorry, that's 180. Oh, that was, man, that's right. That's right. And then if I said, hey, look, go and subtract 180 degrees, well, 180 take away 180 is 0. 360 take away 180 is 180. 540 take away 180 is 360. So it's a lot easier to see than this way. I think that was 180, wasn't it? But anyways, you get the idea. So it's a lot easier with your degrees than it is with radians, in my opinion. So let's look at some more. Oh, good. Azra, how are you keeping up with all this?
Pretty good.
Making sense, right? You get to just do it my way. You won't even know a different way. When you learn it, don't worry about your teacher. Just do it this way. Let's find another one. Let's find another one. New amplitude. We already spoke about all this. I guess we'll do one with this like x on 2 business. There, like that one there. So it's 2 and x minus 3. Yep. We're going to do that, but I'm just going to modify it. Y equals 5. Y equals 5 sine 2 bracket x minus, I don't know, let's just say pi on 2 plus 1. I mean, that's it. That's everything you can get asked. Like, you got to move up and down. You've got a difference in amplitude. You are changing the period because of the 2 times x, and you're even shifting it left and right. That's pretty much everything. If we can answer this question, you're done. You know how to do more. So again, give it a shot just before I start. My clue to you would be obviously to draw y equals 5 sine 2x, right? First you draw that, then you would draw the shift left and right, then you're going to draw the plus 1. So draw the sine 2x, then the shift left and right, and then the shift up and down. All right. I'll leave it with you. All right, let's do it. Y equals 5 sine 2x. So my one would look like this. Again, I know amplitude is 5, period is 2 pi on 2. So I should see one sine every pi, or every 180 degrees. So it'll look like this. That's 180. That's 360. That's 540. You guys get the idea. That's 720. And then same thing this way. That is negative 180. And I don't think I need any more than that. All right, any questions about that? Alex, all good with that? Were you able to draw that out?
Yeah.
What, did you miss any number?
No.
Did you stop at 720, 540? Where'd you stop?
I stopped at 540.
Cool. that should be fine, because like you're going to move at 90 degrees.
Yeah.
You know, it's not, you don't need to draw more than that, so that's okay. And I think 180 is pretty safe again when you're going to move 90 degrees. All right, so that's, you know, you're pretty much 33% there. Then we need to now shift the graph 90 degrees to the right, or we're going to shift our axis 90 degrees to the left. So that means instead of this axis starting here, it's actually going to start right here. That's where negative 90 degrees is. So it's going to be right there. So instead of it being at 90 degrees, now that is at, sorry, instead of being at 0, it is at 90. Instead of it being at 90, it is now at 180. Instead of being 180, it is 270. Instead of it being at 270, it is now at 360 degrees. So we pretty much know our graph now. It's this, there. And last, shift the whole thing up 1. So that means instead of it being at 5, it is at 6. Instead of it being at negative 5, it is at negative 4. Where's your 0? 0 is not there. That's at 1, right? So 0 is just a little bit higher. 0 is somewhere there. Oh, how am I going to draw this in a straight line? There. So that is your 0. Your 0 axis, sorry, yeah. 0. So what's your answer? Stop now, 360. So you can tell just from what I've drawn, at 360, you know what the answer is going to be. It's going to be, this is -1, right? Because that's technically 0. At 360 degrees, it is -1. So if you test it out, you will see that that actually works out. Okay, all good? Any questions? All right, smashed it. So Elle, if you want to do your questions, I don't know, your textbook questions, and even Alex and you guys, if you want to, I mean, when you do it at school or whatever, just redo them now, try it the way I'm doing it, check your answers, and it should all be pretty sweet. It's a lot easier that way. If you want to redraw it, you can redraw it, whatever. I think you guys got the idea. Okay, that's that done. Let's look into some differentiation and integration of this. Missed anything else from the end of the sample? Yeah, so behaviors of sine x. So sine and tan, I just said that to you guys. Differentiating trig, which we'll do now. And then just the integrations in here. Let me see. Transformation, that's pretty much it, just trig equations. What they've got? There must be another trig. Done. It's really weird. Looking setting out of this. Okay. So differentiation. For you, probably this is really easy. So, but let's have a look through this anyways. The trick is this. SC, 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 these two are negatives, and then if you're going down, we're differentiating. If we're going up, we would be integrating. So right now we're just going to be differentiating, so we're only going downwards. Sine 3x, what you want to remember is your angles don't change. So sine 3x becomes cos 3x. Sine 3x becomes cos 3x. And then what you do when you differentiate, you have to differentiate the 3x, which is 3, and you multiply the front of your cos by that. Cool. So let's try this one. Cos x squared. Cos becomes negative sine, so it becomes negative sine. Angle never changes, x squared, times the derivative of the inside, which is 2x So your answer is negative 2x sine x squared. Pretty much that one right there. Any questions? If you have tan, derivative of tan is sec squared x. So what's the answer to tan 3x when you differentiate it? Come on.
It becomes
Angle never changes. Yep.
it becomes like sec squared and 3x times by 3.
Beautiful work. That's it. What about cos squared x? That's a bit different to cos x squared. Anyone have any ideas of how they would differentiate cos squared x, which in other words is this?
Chain rule.
Chain rule, correct. So you bring the 2 down. So y dash 2 cos x, take away 1 is just that, times the derivative of cos, which is negative sine x. And of course you just rearrange and make it negative 2 sine x cos x. So it looks like that one there. From you three, Steph, Alex and Elle, have you learnt this acronym before?
No, I haven't.
Okay, Alex,
And sorry, what was the question you cut out?
have you learnt this before?
Yeah.
Yes, and Elle?
Yeah.
Yeah, all right, cool. That's fine. So, Steph, you understand how to read this now, though?
Yeah.
Yeah, sine becomes cos becomes negative sine. Down is differentiating, up is integrating. All right, and then we'll have a question like this. Cos x on sine x. How do we differentiate two x's that are being divided?
Quotient.
Quotient rule. So y dash equals u dash. The derivative of cos is negative sine times sine is sine squared minus v dash, derivative of sine is cos times cos is cos squared on sine squared x. But what can you factorize from the top?
That equals 1, doesn't it?
Close. What can you factorize from the top?
Negative.
Yes, and then you're left with sine squared plus cos squared, and that's what you meant. That bit there becomes 1, which the answer is negative 1 on sine squared x. Find the equations of tangents. What's the equation of a tangent? What's the equation of a line? Y
Equals,
Nope.
y1,
Yes, y1 equals
m.
x minus x1. X1 and y1 are here. And what's your m? How do we find m?
It's the gradient.
It is the gradient. How do we find it? Find the equation of the tangent to this curve at the point.
Do you have to differentiate the equation?
That's it. We differentiate using product rule. U dash v plus derivative of cos is negative sine times u. So negative x sine x. That's called gradient function. Gradient function. So it's a function that allows you to find the gradient. It is not the gradient. Sub in 90, cos 90 is 0. Yep. And then negative 90 times sine 90. Sine 90 is 1. So the answer is negative pi on 2. That's your tangent for your, that's your gradient for your tangent. And then of course just sub it in. Y minus y1. X minus x1. See, HSC, full marks. But just writing that, you don't need to expand. but obviously we will. But it's good to know how HSC is marked compared to your school exams. Integrating, same thing. Just gonna go the other way around. SC, 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 negative, negative, going up is integration. So that means cos becomes sine, sine becomes negative, negative cos becomes negative sine, negative sine. You get the idea. The thing is, you still have to differentiate, but this time, because we're integrating, you divide by that derivative. So the answer for this, integral of sine, sine becomes negative cos. The angle never changes. But because I've got an angle, it's 2x, I have to differentiate that, which is 2. I don't times it by 2 because that would be for differentiation questions, which is the exercise we just did. We are integrating, which is all about division. So divide by 2. Any questions about that? All right. And again, cos 3x. Steph, you want to try it? Cos 3x becomes? Steph, you might be still on mute.
Oh.
Cos 3x.
Sine.
Sine. What?
3x.
All over.
Divided by 3.
Plus.
Plus c.
Perfect. L. The derivative of tan x became sec squared. That means the integral of sec squared becomes what?
10.
Correct. So therefore, sec squared 4x becomes tan 4x all over 4 plus c. So you just got to differentiate it and then divide by that still. Don't forget that. This one becomes tan theta on 2 all over, derivative of theta on 2 is just a half. It's all over half plus c. Division of half is the same as saying multiplied by 2. So if you could have seen that, you should have written it more like that. Easy. L, you said you hadn't done integration yet of trig, but that's not any harder, is it?
No, it's good.
No. Yeah, and then, I mean, limits works the same way. So like, again, if you follow that SC business, so cos becomes sine. So that the answer to this is sine 3x on 3, pi on 6, 0, sub in pi on 6, take away sub in 0. So it'll look something like this. 3 pi on 6 all over 3 minus sine pretty much 0 on 3. Sine 0 is 0. Sine 90 is 1. So I think the answer just becomes a third. Easy stuff. Let's read this one. It says integrate from pi on 6 to p for sec squared dx and prove that it becomes root 3 take away 1 on root 3 as long as p is between 0 and 90 degrees. Okay, let's see. So what's the integral of sec squared?
10.
10. So tan x, and then what do we write?
P and then pi on 6.
Yeah, easy stuff. Equals root 3 minus 1 on root 3. Finding p. Let's do it. What do you do next then, Alex?
Then you sub in p.
So tan p minus tan 30. Tan 30 degrees must equal to, well, you don't want to keep too many equal signs. Maybe up here. Tan p minus tan 30 equals root 3 minus 1 on root 3. What's tan 30? You'll plug that into your calculator. Do the same thing, Alex. Tell me the answer for what your tan 30 is.
Wait, do you want it with decimals or like the fraction?
We want it as exact values. So yeah, as a
Okay, then it's
fraction.
root 1 on 3.
Root 1 on 3. You mean like this? Or like this? So is the whole, I don't know what you're saying.
Like, isn't it just like 1 on root 3?
That's the one. That sounds better.
Oh, yeah.
Minus 1 on root 3 equals root 3 minus 1 on root 3. What do you do now?
Would you bring the 1
Trying
on
to
root
solve
3?
for p. Yep, you're going to plus that over. So 10p equals, let's just save ourselves a line, plus 1 on root 3. They have common denominators, so you can technically add the top. Minus 1 plus 1, gone. You're left with root 3 on root 3, which is
1.
1. Here we go. What do we do now?
You inverse 10 or whatever it's called.
P equals to inverse 10 of 1, which is 45 degrees, and
that is
sections to central. Now, you didn't need to do all sections central in this case because it's telling you it's between 0 and 90 degrees. But I need to know that you guys can still do it the proper way, which is 10 is positive here and here. So 180 plus 45 is 225 degrees. But you don't need that one. You only need this one here, which equals pi on 4. All good? You can tell which bits you're weak at. And it's not just you, it would be pretty much everybody. It'll just be this bit here. Once they're about to move the plus 1 on root 3, that usually goes very messy. But that's meant to be really easy. So straight away you look at your common denominators, you're like, oh yeah, sweet, I can just add my numerators out. Root 3, 1, gone. Because you know it's going to be a nice and easy number. It's meant to be, especially for the HSC. The exam is set for the whole state, not for your individual school. All right. Sectors and segments. We'll probably look at that next week, but that's more year 11 based work. I think we're technically done with year 12. Oh yeah, let's do it. Let's do this question. Let's do like question 4. So now we'll apply trig and integration to actual areas of curves, which is obviously still just integration. We do know that integration allows us to find areas, right? We're aware of that now. Integration is not area, so don't get that confused. Integration is not area. Integration allows us to find area. So don't confuse it. Okay. Question says, show the area of region. I show you that the area of the shaded region is this. Okay. Okay. All right. Anyone have any ideas of how to start this? We want to find this area here.
Don't you have to do in minus? Yeah.
Yep. And tell me.
So it'd be the top one, which is sine x.
So sine x dx from where to where?
From 5 pi on 6 to 0.
Yep. Yep. Minus.
The line.
You're stuck, aren't you?
Yeah.
Yeah, and that's a good thing. Being stuck is fine. It's not a problem because you don't have the line. Usually you do have the line, so you just go, oh yeah, it's this one minus this one. But
yeah.
What is the line?
I don't know.
It's okay. Being stuck is okay. It's about trying to solve a problem or solve, when you get stuck. Find the solution. So we need that. That bit there won't work. So obviously there is no equation there. So it's not going to be another integral like that. Can anyone tell me what I'm going to be subtracting? It's a little bit I guess, simpler. You're probably seeing it, you're just not saying it.
Wait, Sam, but
Yes.
so obviously there's like a triangle, right?
Of course, see, that's what I mean. You're probably seeing it. Yep, so we can see the triangle.
Yeah.
And what? What do you know? What are you going to do? So what? You see a triangle now. You want to subtract the triangle. I agree with that, but so what? Tell me.
I mean, like I know like the height, I guess, of it, like the base of it.
You know the base of it, which is 5 pi on 6, correct?
But I don't know the height.
Come on, someone help him
Wait,
out.
can't you use you use what's it called?
Come on.
We use the angle or something like that?
No, why? No. Come on, think.
Don't do Pythagoras.
No, too much. Sometimes, maybe different question. I'm not going to take that away from you guys, but you're making it super harder than it needs to be. Come on.
Oh.
This. You want to find the height?
Oh.
Come on. I know we're going to get there. L, any idea of how to find this height? At 5 pi on 6. Come on.
Sine rule.
Sine rule, no need. You guys are overkilling it. Think of graphs and think of points and graphs and stuff like that.
Or half or something like that.
Half, no need. Azra, any ideas? Oh, I feel like you can't say it, Azra. I don't know why. Azra, any idea at all?
No.
Are you sure you got this point to find the height? No.
Point of intersection thing.
Yes. What do you mean?
I know there's a formula.
No. See, this is the problem. You've learnt it only like it's how you started. I said, okay, do you know how to do those in that odd even function question? You're like, I've done it, but I don't know it. Well, then there's no point of doing it. You rather understand what you're doing. It's a lot easier long term. You're right with what you said. But there is no need for a formula. Anyone can see what she's saying? She said point of intersection.
Yeah.
I feel like we've got it. I don't know why.
I feel like I've done so many questions like this, but I don't know.
Yeah. All right, done. I'll give it you guys. It's at 5 pi on 6. To find the y value,
Sub
you
it
sub it
in.
in.
Oh.
I know.
Oh.
It's fine. 5 pi on 6. That's what the height is. Whatever that is. 5 times 180 on 6, 150. Sine 150 is a half. So the y value here is just a half. See how simple that was? I hope by now you've learned. I mean, you see a number, you've got a curve, sub it in. That's just kind of how it's been. We really haven't done much more than that. 5 pi on 24. And that should make you happy because there's your 5 pi on 24. So then you integrate this bit, integral of sine is negative cos 5 pi on 6 and 0 minus 5 pi on 24. I think we already know what the answer for this is going to be. 24 plus 12 root 3 on 24, but we'll prove it, of course. 5 pi on 6 is 150, so negative cos 150 is root 3 on 2. Minus cos 0 is 1, so minus 1, so plus 1. And then you want to make it into a common denominator of 24. So you're going to times that one by 12, times that one by 24, and voila. Let's have a look. 24 plus 12 root 3 minus 5 pi on 24. So two things there that got you guys. The first one, I agree with what you were doing, Steph. You said Integral of the top one minus the integral of the bottom one. You're absolutely correct. Like it would have been an integral minus an integral if you were given the function. When you're not, it's okay. You do what Alex just said, and it's like, oh yeah, that's a triangle, a rectangle, a circle, whatever it is, and then you need to find the area of the triangle, and then you guys just got stuck with the height, which was a simple substitution. So we'll probably continue that. Continue that a bit more next week. But next week, I know you guys want me to go through some of your more integration questions, which involves that, doesn't it? Like that's literally what you're going to get tested on, right? So
Yeah.
we'll literally go through more of those next week. But I'll send you all these booklets as well with the solutions, so you can do that. All right, all good.